Hi everyone, welcome again to my channel. Today we are going to discuss about movie renting system, the design and implementation. So let's dive into the topic. So for the meeting program, first we'll touch upon the system requirement and the functional requirements. Then we'll discuss about the data structures and the entities that we'll be using in this DSA problem. Then we'll go into the detailed logic and pseudocode, and we'll end up with the conclusion. What is a movie renting system and what all functionalities is it expected to do? So the question is, you have a movie renting system, a movie renting company consisting of n shops. So you want to implement a system that supports searching, booking, returning, and reporting. So you'll be given an integer array, 2D integer array, entities, where entity is of I will represent shop, movie, and price, which means that a copy of the movie I is present at shop I with price of price I, and each shop can carry at most one copy of a movie. So the ask is to implement four functions. Search a movie is the first function where the users can search for available movie across multiple shops efficiently by price, which means you'll be given a movie ID and you have to return the top shops which are having a copy of the movie, unrented copy of a movie, sorted by price. The second function would be renting a movie from a shop where a user will buy a movie from a shop. Third would be returning the rented movie. The user which previously had bought a movie from a shop will return it to that shop. Fourth function is rental report generation. This essentially generates a report displaying sorted list of rented movies based on price. So let's understand the problem by an example. So the example is given like this. First, the movie renting system is given where you will be given the entries. So each entry represent which shop has which movie and of which price. Then a list of or a combination of search, rent, report, and drop input, where search represents uh, give me all the sorted list of shops that carry a movie I. Rent represents someone has bought a movie from a shop. Drop represents the one that has previously bought a movie returns the movie to the shop, where report indicates give me the sorted list of the rented movies. And just to note that search and report will return maximum 5 record, not more than that. So let's take this example. I have uh, three shop ID 012, and there are like certain entries 015, 026, 037, 114, 127, 215. And what these essentially represent is shop 0 has movie 1 with price 5. Shop 0 has movie 2 with price 6. Shop 0 has movie 3 of price 7. Shop 1 has movie 1 with price 4. Shop 1 has movie 2 with price 7. Lastly, shop 2 has movie 1 with price 5. Now coming to the second input, which is search 1, which means give me the sorted list of all the shops that carry unrented copy of movie 1. As you can see in the movie renting system, the movie 1 is acquired by shop 0, shop 1 and shop 2. Shop 0 has the price 5, shop 1 has the price 4, shop 2 has the price 5. So search maximum can return 5 shops in the order of price from minimum to maximum. So the minimum one is shop 1 because it carries the movie with price 4, whereas shop 0 and 2 both carry the movie 1 with price 5. So it is 1, then 0 or 2 or 2 or 0. So any order. But here is the catch: if similar shops carry same price, return them in order of their shop ID. So since 0 comes before 2, 0 then 2. So the answer to the operation search would be 1, then 0, then 2. Then the second input is rent. This is 0, 1, which means someone has bought movie 1 from shop 0. Okay. Third is rent, and input is 1, 2, which means someone has bought movie 2 from shop 1. Then there comes report. So what report represents is the sorted list of all the rented movies. The sorted list of all the rented movies. So far we have 2 rented movies. First one is from shop 0 movie 1, and the second one is from shop 1 movie 2. Let's also check the price, the buying price of the movie. So shop 0 movie 1 has a buying price 5. Shop 1 movie 2 has a buying price of 7. So the report always returns the list of shop and movie in the order of price. So it will be 0, 1, then followed by 1, 2. Then comes the next input, which is drop, and input is 1, 2, which means shop 1 movie 2 gets back. The buyer who has bought the movie 2 from shop 1 returns the movie to the shop. Then comes search 2. Search 2 is asking to return the list of shops that has unrented copy of movie 2 in order of price. So let's see which all shops carry the movie sec 2 available, not rented. 0 shop 0 carry movie 2, shop 1 carry movie 2. Yes, and as you can see, we rent shop 1 movie 2, we also return shop 1 movie 2. So now the shop 1 is having the movie 2 available with it. So we have 2 shop 0 and shop 1 carrying movie 2. The shop 1 is carrying movie 2, so shop 0 is carrying movie 2 with price 6, shop 1 is carrying movie 2 with price 7. So it would be sorted on basis of price first. So it would be 0, 2 followed by 1, 2, and search only returns the shop ID. So the shop ID 0, then followed by shop ID 1. So let's now talk about constraint. The number of shops would vary from 1 to 3 into 10 to the power 5. The entries, which means the total number of movies available in total number of shops, would vary from 1 to 10 to the power 5. Movie ID can vary from 1 to 10 to the power 4. Similarly, price of a movie on a particular shop can vary from 1 to 10 to the power 4. Each shop can carry at most 1 copy of a movie, and at most 10 to the power 5 calls in total will be made to the 4 operation, which is search, rent, drop, report. The Test cases would be generated such that the rent would only be called if a shop has an unrented copy of movie, and drop will only be called if shop had previously rented out of the movie, which means we'll always get valid input. You don't have to worry if a input is valid or not. If a shop is having a available copy of movie, then only a rent function will be called. And whenever a movie is already previously rented from a shop, then the drop function will be called. So you can rest assured that all the inputs would be valid. So what is the intuition behind the solution? So as you can see, we are going through a lot of search and report operation, where essentially the system is expecting an answer, and the way to return or the way to evaluate a search or a report operation would be like a map. So for an example, it is asking us to give us all the shops who carry the movie sorted by price. So we can think this is a typical mapping function where we have a map of all the shops from a movie, and that is sorted. So maybe map. So this is a typical use case where the map comes into picture. Whereas in report, it is asking us to return us all the rented movies on basis of price first, then followed by I think shopper movie. So this is again a typical use case where map or set would be used. So the whole system, the whole movie renting system would be a use case of set or map. So let's understand it. The movie renting system can be modeled as a sorted set of rented and unrented movies, right? So the whole system will carry rented set where all the rented movies would be captured, and unrented movie set where all the available movie would be captured. Whenever someone rents a movie, we move that element from unrented movie set and add it into rented movie set. And when someone returns a movie, we do the opposite. So this is the simple yet crucial intuition behind the movie renting system. Now let's go to the solution where we will be using these data structures to solve the problem. So before jumping into our algorithm, let's first understand the important variables that we'll be using to solve this problem. The first one is price table. So price table essentially is required when we want to know for a given shop and a movie what is the price. So we want a typical map from movie and shop to price. So the data structure would be unordered map from shop and movie pair to price. So we'll be creating basically unordered pair, unordered map of pair to price. So where pair is nothing but shop and movie. So this would be used to quickly know the price of a given movie in a given shop. The second variable would be rented movies. So rented movies list all the rented movies in order of price, shop and movie. This will be used when we generate the report of cheapest 5 movies. And the data structure that we'll be using is map of price to a set of shop and movie. If you see, the elements would be sorted on basis of price because this is a ordered set, and ordered set always gets sorted based on the key value. So the key value is price. So the first element in this list would be the minimum price. And why are we keeping a map from price to shop and movie? Because multiple movie can carry same price. So let's say movie 1 in shop 1 carry 10, movie 2 at shop 2 can carry 10. So the price 10 can belong to multiple movies at multiple shops. So we are basically carrying a map from price to a list of shop and movie. And why are we maintaining shop and movie in form of a set? Because if there occurs similar price, same price for multiple movies at multiple shops, how to return them? So the report function, the generation of report, should be done in such a manner that the movies would be sorted based on their price. But if the price matches, then it would be sorted based on shop, and if the shop matches, it would be sorted based on movie. So the map typically sorts all the movies first on basis of price. Then for each price, we are sorting the pair of shop and movie in form of shop ID, then movie ID. So in total, this particular data structure or the variable would help us generate the report in the correct order. The third kind of variable would be unrented movies. Unrented movies would be helpful while we generate search, while we search a movie. So when we search a movie, we return all the shops that carry unrented copy of that movie based on price. And if the price matches, it would be based on shop. So in order to fetch all the shop that carry a movie sorted on price, will keep a unordered map. The unordered map would be from a movie to a particular shop with a given price. And since the return value would be sorted based on price, the value of the unordered map would be set, and that set would be a pair of price and shop. And price comes first, so it would be first sorted based on price, then comes shop, then if the price matches, it would be sorted based on shop. So the unordered movies variable would help us in searching a movie operation. These three would be sufficient to solve our movie renting system. But there are some additional improvement we can introduce by keeping some extra variables. So take this scenario. I will ask you give search movie 10. So you'll calculate from unrendered movie set, and you will fetch first 5 result and you will return. Next, I'll ask you the same thing, search movie 10. So you will again go and you will check the unrendered movie set, and then you will fetch the 5 top result and you will return. So this is not efficient, right? If you already calculate the search of movie 10, there is no need to calculate again search of movie 10. So there comes a need of cache. So to fetch the search and report function efficiently, we introduce two cache. The first one is unrented movie cache, so which we just talked about. If the search is already done and there is no change in between, the next search would just fetch it from the cache without going and evaluating it again from the unrented movie variable. So that is the main purpose of unrented movie cache, and it would be an unordered map from movie ID to vector of shop. So basically vector of shop is the one which is the return type of search function. So unrented movie cache is solely made to make the return the search function faster. Similarly, we'll maintain rented movie cache. So the rented movie cache would be helpful to efficiently return the report or generate the report. So let's say I generate the report now and there happens no change into the rented movie, and I'll ask the report again. So there is no change at all, right? So we can safely store the result of report now, and after some time, if there happens no change, we can return it again. So to store that report, we'll use the variable rented movie cache, which caches the result of last report, which is cheapest 5 rented movies, and basically it helps to avoid recomputation if no change occurs. So these are the 5 variables that we'll be utilizing while we implement our movie renting system. So let's now go ahead and check how each function operates using these variables. So first is initialization. So during initialization we will carry the n, which is number of shops, and will instantiate our movie renting system. As an input we'll get all the entries. So when we get all the entries, we'll add those entries into unrented movies and price table. So price table for a particular shop and a movie would be the price, and those entries would be added to unrented movie set. So unrented movie set is a map from a movie to a pair of price and shop. So for each entry, each input entry, we will make an entry to our price table. Also, well, we will make an entry to our unrented movie map. So let's now go ahead and see how each operation would be implemented. Rent. Rent a movie from a shop. So when we rent a movie from a shop, the first thing is we will remove that from the unrented movie set. We will add that into the rented movie set. That is the two basic operation we will perform. So to remove uh, a particular movie from unrented movie shop, we have to know the price. So price can be easily fetched from the price table. So we'll remove it from the unrented movie set. We will add it to the rented movie set. Now, since we are making change to the rented and unrented movie set, we will clear the unrented movie set movie cache as well as rented movie cache. So please note that unrented movie cache is a unordered map from a movie to its listed shops. So we don't have to clear the whole cache, we just have to clear the cache for that movie. So if you're dealing with movie 2, we will clear movie 2 from the cache. Now coming to drop function. So drop is the opposite of rent, which means someone who has rented a movie will return the movie to that shop. So we will add that movie into the unrented and will remove it from the rented, and also will clear both the cache, because now we are changing both unrented movie set as well as rented movie set. So so the cache no longer is valid. So we have to clear the cache. So this is exactly the opposite of rent function. Coming to the search operation. Searching a movie, which means give me 5 cheapest shop that carry unrented copy of the movie. So first thing is, as you know, for search we are already maintaining a cache. So if we see the movie is present in cache, so fetch it from the cache and remove it. Straightforward. If not, we'll go ahead and we'll calculate it. And how will we calculate it? We will calculate it using our unrented movie list variable. And in the unrented movie set variable, the list is already sorted based on price and shop. So we'll fetch first 5 and we'll return it. And when we return it, just before we return it, we'll add it into the cache for the efficient data fetching in future. Coming to report function. So report would give us the cheapest 5 rented copy of all the movies. So again, for report we are maintaining a cache. So if we see the result is already present in cache, uh, so return cache. So just pardon the mistake, the printing mistake in if statement. So what is written in the if statement is if rented movie is not empty. Okay, so if rented movie cache is not empty, which is correct. So if the cache is not empty, which means the cache is present, so return it. If not, go ahead and calculate it. So how will we calculate the 5 cheapest rented movie? We will basically use our rented movie list. The rented movie list is already sorted based on price and then shop, then movie. So it is an ordered map from price to a set of shop and movie. So I'll try to fetch first 5 values, and that's it, and I'll return it. But like in search function, here also before returning the final result, we'll save it into the cache. So we are at end of our implementation, or we can say pseudocode. So here we initialized our movie renting system by adding the entries to our price table to our unrented movie list. Then for each of the function like rent, drop, search and report, we keep updating the variables, and we efficiently managed to return the search result and report result by introducing two cache. So in conclusion, we discussed about functional requirements, we discussed about the data structure design, like what all entities we will be using and why we'll be using such entities. Then we went through the pseudocode and discussed all the steps starting from initialization to the method implementation. So if you're interested, you can go ahead and give a watch to my article of this problem, which I have added in the description. So thank you all for listening. Keep coding, keep rising. So until next time.